Hey guys, Mr. Adamson here. Welcome to another lesson in Science 14. Previous lesson we talked about heat and a few definitions that went along with it. Difference between heat and temperature being the average of all kinetic energies, heat being the sum of all kinetic energies. And now we're going to talk about ways to transfer heat. So the forms of heat transfer. Now, heat flows naturally from hot to cold until both objects are the same temperature. So if you're ever sitting on a cold floor, your cold desks, your body's usually warmer and the heat's gonna flow out of it to that cold spot until it's the same. Now there are three forms of transfer, and they are conduction, convection, and radiation. And if you kind of look right here in this picture, it kind of really shows what all three are about. Conduction, you can see, is by touching something. Convection is through air and liquid particles, and radiation is through waves. Now, conduction. Conduction is a transfer of heat by contact. So if we look first at this picture here, so heat transfers through a solid. Speedy molecules in the heating coil bump into the pan molecules. Now the fast pan molecules then bump into the bacon molecules, heating it up. And again, the bacon is cooler than the pan. It's going to transfer to the colder object. Now, if we look here in relation to a house in a summer day and a winter night, we can see that heat flows through materials. Now, heat conducts from the warmer to the cooler side of a window as each molecule excites its neighbor, passing the energy along. Now, conduction occurs through the glass, the window frames, and even the air or the inert gas filled between the glass layers. And so on a summer day, you have the hot air flowing into the cooler house, and on a winter night where it's warmer in your house, you have that air going outside. So it's going naturally from hot to cold. Now, convection. So heat is transferred from a hot object to the air molecules touching the object. These molecules gain kinetic energy, vibrate faster, and get further apart. These warm molecules are farther apart than the cooler ones, so the warm air is less dense than the cool air around it. This warm air rises, making the warm current that you feel. Cool, denser air rushes in to take the place of warm air, and because of this continuous flow, all the air in the room will become warmer. So if we look here in this picture here, we have a radiator or a heater within a house. The cold air is going to come along the floor, and as it heats up, it's going to become less dense, rise up, and as it's up in the ceiling, it's going to eventually start to cool off and circle back down again. And so you continually get this flow, and that's why you're going to see fans usually. So if we had a little fan, let's see, up here, and it's going to be spinning, and it's going to be pushing the cold air back towards the ground. So as this warm air comes up there, it's going to cool off, and again continue with this circular motion to keep it warm. And you also get the flow of air there, and it's going to feel cooler sometimes on warm days. Now, if we look at this picture here, so convection again is the movement of matter in the form of currents. Convection occurs only in liquids and gases. And so we can see here we have warm, fast molecules that are near this hot plate right here. The less dense air rises, so the warm air, it cools and begins to sink back down, and the cold, slower molecules replace the rising warm air. So again, we have that continuous circular movement of the air molecules. And the last form that we talked about is radiation. Now, radiation is produced by vibrating electrons, which are tiny particles present in all atoms. Now, the vibration makes a wave called electromagnetic or infrared radiation wave. And these waves are similar to the wave your hand can create when it vibrates in calm water. So when you're just sitting there in calm water, and if you start moving your finger, you see the waves dissipating from your finger and moving away from your finger. Now, infrared radiations travel from hot objects. And so just like this is in relation to the Earth and the Sun here, we have the hot sun is sending radiating waves to the Earth. Or if you're sitting around a fire, if you're out camping, you have the waves coming from the hot fire, so those radiated waves towards your hands and warming them up. Now, heat transfer in nature. So we know already, because of convection, that warm air rises and cool air sinks. Now, the circular movement that results from this is called convection currents. And all the wind you feel starts with convection currents. Land and sea breezes are convection currents of air that occur near a shoreline. They are both created by differences in the temperature near the surface of the earth. So, in relation to how we feel and how our temperature is, this is our planet here. We continually have circulating motion of air currents all around the globe. And these are known, if this would continue all the way around, of course, and this is Earth, and this would be the convection currents. So we continually have that hot air rising and that colder air circling in. Now, here's a little did you know. So mountain breezes affect the climate of Calgary. So at night, air near the mountains cools, sinks, and flows toward the valleys in Calgary. The mountain breeze cools the city. Now, why does Grande Prairie, though, have so many thunderstorms? The answer is the number of shallow lakes nearby. The shallow lakes quickly heat up during sunny days. Warm lake water heats the air, causing it to rise. As the air rises, it cools and sinks back to the lake. This cycle of rising and sinking air builds convection currents, and these currents often create thunderstorms that are so common in the area. So the closer you are to bodies of water, you may get more thunderstorms, but you also sometimes get a more stable set of temperature values. So instead of being like we are around this area, we can go from -40 all the way to +40 here. You're going to be, instead of being at this kind of range and this range, you might be in this range and this range of temperature. So those bodies of water can help moderate, and we're going to talk about that. Now this picture here shows in relation to land breeze and sea breeze. So if we look here at the land breeze, we can see at point A right here, the sea loses heat more slowly than land, and the air over the sea is warmer. The warm air rises over this, warm air over the sea rises, and that's B. Now at point C here, the air over land is cooler. Cool air is more dense and sinks, and so we can see it actually coming down. And if we go to point D, the cool air flows towards the sea to replace the warm air that has risen. And so what this is saying down here is that a land breeze is a mild wind that flows from land to ocean. Land breezes usually occur in the evenings. Land breezes often serve to carry air pollutants out to sea, away from coastal cities, because we can see the flow of the convection current here going up to sea. And land breezes are weaker than sea breezes because there is less temperature difference between the land and the sea during the evening. Now if we look here at sea breeze, we start at point A. The sun's rays warms land more rapidly than they warm water. If we go to B, warm air is less dense, warm air rises, and we know that. If we go to C, air over water is cooler, and cool air is more dense and sinks, and we know that already. And we go to D, cool air flows towards land to replace the warm air that has risen. So a sea breeze usually occurs on a hot summer day. If you are close to shore, you will feel the breeze blowing from sea to land. This is a sea breeze. A sea breeze is a cool wind that blows from the ocean or the lake towards land. It is a cool and welcome relief on a hot day. So usually you can see some of the big differences. Land breeze, more likely occurring at night. Sea breezes more likely occurring at daytime here with the sun. Okay, and you have a reverse. Land breeze, you have the cool air coming towards the land and circulating down and back out to sea, whereas in the sea breeze you do have the cool air coming towards land but circulating up. It's just the complete opposite of one another, because in the sea breeze the land is usually warmer here, you can see at 28 degrees Celsius, whereas in the land breeze it's cooler at 12 degrees Celsius. Now, how oceans help to moderate the climates, like I previously was talking about there. Oceans are able to store large amounts of thermal energy, and this prevents the area from around them having huge temperature changes, so they moderate the temperature. In cool weather, an ocean can release a great amount of heat without cooling itself. And as the sun warms above the ocean, heat flows from the air into the water, cooling the air. When the temperature of the air above the ocean cools, heat flows from the ocean to the air and warms the air. So now, using this knowledge, how could you explain the temperature differences between Vancouver and Calgary? And that's where I was talking before. Whereas in Calgary, we have a -40, and we can change all the way up to +40. I mean, in wintertime, we can go from -40 to -10, which is a 30-degree difference, and that's a pretty drastic change. So we have a pretty big spectrum here. And we don't have any large masses or bodies of water around us to help moderate that temperature. Where in Vancouver, they're maybe going to go from maybe get as cold as -20, and I mean they can get all the way up to +42, but they're most likely going to go from maybe a -10 range to that +30 range. So they have a lot less, and they're not going to see that 30-degree difference here from -40 to -10 that we see out in the central Alberta area here, like in Calgary. They're only going to see a few degrees difference at a time because that large body of water, the ocean, the Pacific Ocean there, is going to moderate the temperature. So that's it for now on heat transfers. Hope you're able to take something from it, and thanks for listening.
Made with Doodlecast Pro.